Okay, so hopefully you've come back for the second lesson. So in the first lesson, we looked at PyTorch Lightning and we also looked at scikit-learn. So in this second lesson, what we're going to do is we're going to try to improve our performance just a little bit. Hopefully you've had some time to go ahead and build your own model in this kind of framework and have a play around with some of the data sets that you might have. So one of the ways that we can improve this model is simply by adding more layers. So let's have a look at how we can do that in PyTorch. So to do that in PyTorch, all we need to do is we need to define a new layer, like so. And we need to make sure that the inputs and outputs of this layer match what we expect. Now in this particular case, what we've said is in the top layer, input size is size 4, output is size 3. Let's change this. Let's change this to 5 because we feel like it. Remembering that the output still needs to be the same size as the number of labels that we have. So let's change this to 5.3 as well. So that means that the input has size of 4, an output of 5, and then in the second layer, the input is of size 5 and the output is of size 3. Okay, so let's do this like that. That means, what this means is when the model is called, it will first go through the first layer, and then using the output of the first layer, it will go into the second layer. However, this isn't where the strength of deep learning lies, but rather what you want to do is you want to introduce some kind of non-linearity. So we're going to use the ReLU function, which is the rectified linear unit, in order to do that. So now it goes through the first layer, applies a non-linear activation function, and then uses the output of that to go into the second layer. Alright, so let's go and try to run through this whole example again and see whether we get an improvement in our performance. So let's wait for this to go for a little bit. So one of the really useful things with PyTorch is you can see how many parameters it needs to optimize compared with if you didn't have this. So saying that in the first layer there's 25 free parameters and in the second layer there will be 18. So every single time it's running an epoch, it is updating the parameters used for both of these. Alright, so now you can see that by making a very simple change and adding this non-linearity, we now have demonstrated we have superior accuracy to the scikit-learn solution, and we have a lower log loss as well. So you can see in our torch solution 0.91 and our loss is 0.38, our log loss, compared with our scikit-learn, which is 1.51. All right, and let me try this for a moment, just to double check that we get the same number. All right, 1.519. So there we have it. We've demonstrated how you can extend your existing PyTorch model by adding an additional layer, just by adding an extra 3 lines of code. And now we can build a model that surpasses what we have in scikit-learn in a very easy to use way. At the end of the day, once we have defined our model, it's only 3 lines of code in order to train it. And that's very similar to scikit-learn, where we have 3 lines of code, except that this model, of course, we can't alter this after we've built it, and we'll need to do a lot of work in order to change what actually happens as part of this model. So hopefully you found this useful and that you can go ahead and try lots of different things within the deep learning space, and remembering that it isn't really all that difficult in order to get your in order to dip your toes and begin to build some deep learning models.